Okay, so let's talk about inequalities for a second. They're not super duper difficult. There are two rules that we need to remember when doing this, though. Rule number one, knowing when to flip the inequality sign. Actually, let's talk about what inequalities are. So an inequality is anything, you're familiar with the equal sign, but it's all the stuff that's not the equal sign. So inequalities means that somebody has more than somebody else, right? That's an unequal distribution. If I have more money than somebody else, then the money is not distributed equally. If after Halloween you have more candy than somebody else, then that candy is unequal, right? So the inequality signs are greater than, because somebody might have more, less than, greater than or equal to, or less than or equal to. Now, this is really important. We read it from left to right, just like when we read books. So, so some people have trouble figuring out which way to point everything when they're reading the questions, greater than or less than or whatever. Whenever we're talking about inequality signs, and people hate it when I do this, but it works. If I think of this as some kind of Pac-Man monster, the mouth is always open towards the bigger number, right? We always talk about this in elementary school. It's got these crazy pointy teeth and this crazy empty eye, and it's going to eat whatever's bigger. So if I said x and 4, x is greater than 4, right? Because it's going to go and eat the x. Well, what does that make x? What's the value for x? What's the answer, right? The answer is literally, it's everything. It's all the numbers that are bigger than 4. So 4.0001, also 4 million, and all the numbers above either of those. So anything greater than 4. And so we represent that on a graph in a very special way when we talk about that. So if I start at 4, it's everything, not including 4, it's everything greater than 4. So let's say this is like 8 and this is like 0. It's greater than, so it's going to go towards the positive numbers. Okay, so let's go ahead and jump right into the rules. The rules are, when you're dealing with inequalities, it's going to be just like regular equations. So regular equations, I'm going to subtract 2 on both sides so that I can get the x by itself, right? And the number by itself on the other side of the equal sign. With inequalities, it's basically the same thing. You've got x plus 2 is greater than 4. And then I can subtract 2 from both sides of the inequality instead of the equal sign. And x is greater than 2. No problem, right? We solve these just like regular algebraic equations. So let's talk about the ways that they're different now. So we've talked about the ways that they're the same. There is a time where you're going to flip the inequality sign. So it will change from a greater than maybe to a less than sign. And this is when it's going to do it. When you multiply or divide by a negative. That's the rule. When you multiply or divide by a negative, you flip the inequality sign from whatever it was to whatever it is. And we're going to explore why that is here in just a second. So when you multiply, that's a key word, or divide, that's a key word, by a negative, that's a key word. Please write these down. Keep it somewhere as notes. Hang it on your wall, whatever you want to do. Put it on your ceiling so it's the first thing you see when you wake up in the morning. You flip the inequality sign when you multiply or divide by a negative. Not when you add or subtract. Not when you add or subtract a negative. Only not when you multiply or divide by a positive. Only when it's both conditions, when you multiply or divide by a negative. Got it? Good. Okay, so let's look at some examples. So if I have negative 2x is greater than 16, let's do greater than or equal to so we can get some practice seeing that. See how it has half that equal sign right there? So greater than or equal to, because it has the little half of an equal sign there. Okay, so how do we solve this? Well, we divide both sides by negative 2. Negative 2 divided by negative 2 is 1. 1 times x is just x. And then 16 divided by negative 2 is negative 8. Did we multiply or divide by a negative? You betcha. We divided by a negative. So now we're going to do what? Now we're going to flip the sign. So instead of greater than or equal to, it's going to now be less than or equal to. And that way, when I graph it, let's make a little graph right here. When we graph it, it's just on a number line. So it's nothing fancy. Here in the middle, I'm going to put my negative 8. And this time I'm going to fill in the dot because it also includes the number 8. Because if I put 8 in for x, 8 is less than or equal, negative 8. Negative 8 is less than or equal to negative 8, right? Because it is equal to. So it fulfills that part, so the whole thing is good. Okay, so since it also includes negative 8, I'm going to fill in the dot to show that, yes, negative 8 is part of our solutions, and it's everything less than. So which way is less than? Let's say this is negative 20, and this is positive 20. Less than. Which way does less than go? Does it go towards the big positive numbers? No, because that would be greater than, right? So it's going to go to the left. This is less than. Less than or equal to negative 8. So that's kind of a crash course on how we graph these two. So those are the two things that make these different. Number one, there's the rule that you flip the sign whenever you multiply or divide by a negative. And number two, when you graph these, they're going to look a little funny because the answer to these questions is a bunch of numbers, right? Negative 10 is less than or equal to negative 8. Negative 130 is less than or equal to negative 8. Negative 8.00001 is less than or equal to negative 8. And so you've got all these answers. How do we represent that on a graph? Well, we start on the number line where it's true, and then we shade in all the areas where it's still true, because it's still true. Negative 20 is less than or equal to negative 8, and all the numbers behind it. Okay, so that is a crash course on how to do those. So let's do a couple of examples really quick. If I have negative 2x plus 4 is less than 16. So we're going to solve this just like a two-step equation. I'm going to subtract 4 on both sides first because I'm saving this, right? We're saving that, and so I'm going to subtract by 4 on both sides. A plus 4 and a minus 4 cancel each other out, which is the point. We want to get the negative 2x by itself. Did we multiply or divide by a negative? No, so we're going to keep the sign the same. 16 minus 4 is 12. What's the next step? We're going to divide by negative 2 because between the negative 2 and the x, that's multiplication. So we're going to divide instead. And these cancel out. And so x and negative 6 are on either side of each other. Did we multiply or divide by a negative? You betcha. So x is greater than negative 6. See that? We changed the sign. Why? Because we multiplied or divided by a negative. Now, for the other funky part, how the heck do we graph that? Let me put a graph up here in the corner where it makes zero sense at all. I apologize for that. So if I start at negative 6, can we put a negative 6 in for x? Is negative 6 greater than negative 6? No, so we're going to actually have an open circle here because negative 6 is not included as part of our answers. So x is greater than negative 6. Are we going to go towards the 2 or are we going to go towards the Negative, wait, let's see. It's 6, 8, negative 14. Greater than, we're going to go towards the positive numbers, right? So it includes all the numbers that are bigger than negative 6. Okay, great. Give it a shot. Let me know how you do. Let me know if you need help.